Welcome to the Walton Pi. Today I'm going to go through this problem from Abstract Algebra that has to do with R modules. So suppose that I is a principal ideal in the integral domain R. We are asked to prove that the R module I tensored with I over R has no non-zero torsion elements. Okay, so how are we supposed to go about doing this? Well, to start off, let's use the first isomorphism theorem for modules. So what this says is it says that if you have phi defined from M to N is an R module homomorphism. Then what we have is then that means that M modded out by the kernel of phi, whoops, wrong phi, is isomorphic to the image of M. So this is what we're going to be using, and in this case what we have is we are trying to figure out what on earth are we supposed to use, how can we use this to help us out? Well, what we're going to do is we are going to define phi defined from R to I, where I is our principal ideal, and specifically we're going to say I is equal to some value xr, where it's a principal ideal, so it's generated by a single element with R. So this is going to be equal to phi of R is equal to xr. Okay, so this is going to be an R module homomorphism. So that means that R modded out by the kernel of phi is isomorphic to I. Now what's the kernel of phi? Well, R modded out by the kernel of phi, these are the things that go to 0. Now this is equal to R modded out by the things that get annihilated by x. And what are the things that get annihilated by x? Well, the things that get annihilated by x, these are the things that are in R. So these are the r's in R such that xr equals 0. Well, because we're in an integral domain, that means that the annihilators of x, this is equal to, we have two different options. It's either 0 if x is not 0, or r if x is 0. Now, we're assuming that we're not wanting to just get rid of everything. But what this means is that R modded out by the kernel of phi, this is equal, or isomorphic, to R modded out by 0, which is isomorphic to R, exactly when x is not 0. And if x is not 0, then that means I is really just isomorphic to R. And so what this means is, here, let's zoom out so we can still read the problem. Alright, so what this means is so if I is not equal to the 0 ideal, okay, then I tensored with I over R, this is isomorphic to R tensored with R over R, which is isomorphic to R, which has no non-zero torsion elements. And because we're assuming we're a principal ideal, I'm assuming that this is a non-zero principal ideal. Because if we are the 0 principal ideal, then the only element is 0, and so then, again, we're also going to be done. And so here we go. That is how we would approach this problem. I guess maybe I should specify that. So if I is equal to 0, then the only element is 0. And so we are done in this case as well. So there we go. That is the complete proof of this problem. If this was a video you enjoyed, please consider liking and subscribing, and please check out some of my other videos, and I hope you all have a great rest of your day, and good luck with all of your math.